So our last section is actually a review if we've graphed linear inequalities before. So I'm going to recap this real quick and then we're going to just get into the application. But when we have y is greater than, not equal to, then we use a dashed line. If we do greater than or equal to, when we say equal, then we will use a solid line. If it's less than, and we say not equal, just less than, then we also use a dashed line. Less than or equal to, when it's equal, we will use a solid line. Greater than, where a value is greater than that line, remember y is not left and right, y is up and down. So we would shade this up, greater than we'd shade up, less than we both on those shade down. Okay? These are not ready to graph. So you're going to need to get these in y equals mx plus b. So when I look at this first equation, to solve for y, we're going to subtract the 5x. And get 3y is greater than or equal to negative 5x plus 6. And then to get that to be y equals, we divide everything there by 3, so that y is greater than or equal to negative 5/3 x plus 2. That will be our first equation. Second one's a little trickier. Still the first same step, moving the x over. So negative 4y is less than or equal to negative 3x minus 8. Dividing by the negative. Y is, don't forget when we divide by a negative, the inequality will flip. Positive 3/4 x plus 2. What does this look like? Well, we graph this using the y-intercept and the slope. So the first equation had a y-intercept of 2 and a slope of down 1, 2, 3, 4, 5 over 1, 2, 3 to get to our next point. It says y is greater than, so I will be shading above this line, but I do recommend that you wait on that. Okay, that's what we would have done before. So for the second one, we also have a y-intercept of 2. That one has a slope of positive 3, so up 3 and over 4. Or down 3 and back. Didn't do that very well. But down 3 and back 4. That helps me get kind of more of a straight line there. Okay. Now remember, we wanted to be shaded above our first line, and I also want to be above our second line. I see kind of 4 regions. Some of you might be able to look at this and just see which one is above both those lines, okay? Is it this region? Well, this is above the first line, but it's actually below the other one, so it's not the top left. Is it the bottom left? Well, that's below both lines. That's not what we want. That's kind of not at all. This one is above one of the lines, but below the other. I want above both. Above both would be up here. Another way of visualizing this, and our solution is going to be that overlap, but another way of visualizing this is I can shade everywhere above the first line. Okay. And then I can shade everywhere above the second line. And where's our answer? Well, yellow and blue overlap to make green. Our answer is where they're both true, only in that shaded region. Okay? Alright, so we can check the following points. Is 0, 0 a solution? Well, I see 0, 0 right here. That doesn't look like it's in that overlap shaded region. I'm going to guess no, just by the picture. But you need to be able to check this algebraically. How do I check it algebraically? I plug in the x and the y into both equations. So 5 times 0 is 0. 3 times 0 is 0. Is 0 greater than or equal to 6? I'm going to say no. This is not a solution. If I plugged it into the other one, 3 times 0 minus 4 times 0, 0 minus 0 is not less than or equal to negative 8. This is not a solution. It's not in the shaded region. It's not on the lines. What about 0, 2? That's that y-intercept, right? Is that a solution? Is on the line of solutions. Well, I can check it algebraically. Go back to the top equation. What was it? 5 times x. 5 times 0 is 0. 3 times y. 3 times 2 is 6. Is 6 greater than or equal to 6? Yes, it is. That doesn't mean it's our answer. Remember, it has to work for both. So check the other equation. 3 times 0 is 0. Negative 4 times 2 is negative 8. Is negative 8 less than or equal to negative 8? Yes, it is. That means that on the line is a solution because they're both solid lines. What about 2, 1? Well, 2, 1 is right here. It's in that blue region, right? Well, when I check it algebraically, the first equation, 5 times 2 is 10, plus 3 times 1 is 3. Is 13 greater than or equal to 6? Yes, it is. But for it to be true, it has to work for both. So let's check. 3 times 2 is 6, minus 4 times 1 is 4. Is 2 less than or equal to negative 8? No, it's not. So even though this worked for 1, even though it was shaded in the shaded region for 1, this is not a solution. Why not? It has to be in the area where they both shaded or on the line. So our solutions for this are going to be any point in the shaded region. Now remember, that shaded region is the shaded region that they share, or on both lines. And why does this work on both lines? Because both lines were equal to. Both lines were solid. Next one. These are not in graphable form, so we got to solve for y. Move the x. So we get that y is greater than, how about negative x minus 2? Go back to that in a minute. Second one, we got to move the 2x. So that negative y is less than negative 2x plus 3. That is not ready to graph. That is not y equals. We need to divide out the negative so that y is greater than 2x minus 3. What does this look like? Well, the first one has a y-intercept of negative 2 and a slope of down 1, right 1. Down 1, right 1. If you draw this line, you've made a mistake because this was not equal to. This line should be dotted. Get your eraser and make the line dashed. Second one has a y-intercept of negative 3 and a slope of up 2 over 1, up 2 over 1. If you made the line solid again, go back and erase it. Because what? This was a dashed line. This was not equal to. So the line should be dashed. Okay? How do we shade? Once again, they're both greater than. So I'm looking for greater than our first line, greater than our second line. I'm going to know that's in this region. If you're not sure, highlight. I've seen some people do this. This to me gets a little messy. But I have seen some people that will go horizontal lines this way, vertical lines this way, and then darker in the middle where they overlap. I think that gets messy. But if you keep track of it, I can kind of, as long as you know that our answer is only where the two regions overlap, only in that middle part. Okay? Let's look at the following points. Negative 2, 0. I don't know. It looks like it might be on one of the lines. Is it a solution? Check it algebraically. X is negative 2. Is negative 2 plus 0 greater than negative 2? Is negative 2 greater than negative 2? No, it's not, is it? That means this is not a solution. We could check the other one anyway, just for fun and giggles. Negative 2 times negative 2 would give me negative 4 minus 0 is less than 3. That is true. Negative 4 is less than 3. But still, this is not a point. Why not? It has to work for both. So the idea is that even though it fell in the right region for 1, on the line didn't work because this was not a solid line. It was not equal to. What about 0, 0? Well, it looks like it's in the shaded region, so I'm going to say yes. But let's check it algebraically. 0 plus 0 is greater than negative 2. That is true. And on the bottom, 0 minus 0 is less than 3. That is also true. So for it to be true, it has to work for both. So yes, the shaded region worked. What about 3, 0, 1, 2, 3, 0? I'm going to guess no, because it's not in the shaded region for both. Check the first equation. Is 3 plus 0 greater than negative 2? Yes, it is. Did we make a mistake? Remember, it has to work for both, right? So check the other one. Is 6 minus 0 less than 3? No, it is not. So where is our solution this time? Our solution is in the shaded region. But not on the lines. Why not on the lines this time? Because the lines were dashed. If they're dashed, then the not equal to means that the lines are not part of our solution. Last but not least, this should be pretty easy. 2 of these are already to graph. The last one we need to solve for y. Greater than. Divide by the negative. We divided by a negative. The fact that that 2 is negative means that when I write this inequality, the inequality must flip. Okay. So what does this look like? Well, 3 halves x minus 3. I go to the y-intercept of negative 3. I go up 3 over 2. Up 3 over 2. And we've got, I hope you didn't just draw a solid line, because this is not equal to, which means the line should be dashed. We are going to end up wanting to shade below this line. I'm going to save that for now. How do I do y is greater than or equal to 3? Well, that graph's just like y equals 3, so that would be a horizontal line at 3. Why is it solid this time? That equal to makes it solid. How do I, greater than means I'm wanting it above this area. Interesting. X is less than or equal to 4, so I go where x equals 1, 2, 3, 4, and I draw a line that is solid, going straight up and down. And x is less than is not up or down. X values are left and right, so I'm going to want to the left of this. So I want below the dotted line, above the solid line, and to the left of this line. I don't know. This may not have a shaded answer. Let me look. Y is greater than or equal to 3. That would be above this line. Below the second line. But everywhere to the left of this line. I don't see a common area where they're all shaded. Those two overlap there, those two there, those two there. Interesting. Okay, so I messed with this a little bit. They're going to have some like this where they're going to look for the overlap of all three. This would have no overlap of all three, so I'm going to go through this briefly. Would 0, 0 work? No. Why not? Well, it's in this region where it's kind of one of them, right? So if I plug it into the first equation, in place of x and y, we say 0 is greater than or equal to 3. That is not true. If I plug it into the second one, 0 is less than or equal to 4. That is true. And if I plug it into the third one, I get that 0 minus 0 is greater than 6, which is not true. So that was only in the one region they had in common. 1, 2, 3, 4, 0. Let's check the 4, 0. It was y first, right? Let's look. Y was... Okay. Is 0 greater than or equal to 3? No, it's not. Is 4 less than or equal to 4? Yes, it is. And is 3 times x is 12 minus 0 greater than 6? Yes, it is. This is still no. For it to be yes, it has to work for all three. 2, 0. Is 0 greater than or equal to 3? No. Is 2 less than or equal to 4? Yes. And the last one, 3 times 2 is 6. Minus 0 is greater than 6. That is not true. So none of these work. Why? We don't have really an overlap for all three. I didn't intend for it to be like that, but it's not a big deal. Just make sure that you shade in all the right directions and find where they all three overlap.